All right, Math 1B, this is part 2 of video 5.4. So hopefully you started to get the hang of the whole idea of how do I factor if there's 4 terms in the polynomial where not all 4 of them actually share something. What we talked about was regrouping them in such a fashion that, the way I'm looking at this is I like the 14x squared and the negative 7x side by side. These two don't seem to share anything, but you know what? We got to group 2 people together. So there they are. So the blue group pretty clearly divides out a 7 and divides out an x. Okay? So the 7x is the greatest common factor of these 2 terms. The 7x goes on the outside of parentheses. The inside of the parentheses gets replaced with 14 divided by 7, which is 2. X squared divided by x, which is just x. So 2x is what goes here. 7x divided by itself, anything divided by itself is just 1. So there it is. So here's the tricky part. All right? Tricky part is this. You are trying to make this black ink group look exactly like this blue ink group. So we need to divide something that creates a 2x minus 1. We need these to be identical twins. So what do you divide negative 2x plus 1 by to get 2x minus 1? Hopefully you guys notice that it should be negative 1. If I divide by negative 1 here and divide by negative 1 here, a negative divided by a negative is a positive 2x. A positive divided by a negative is negative 1, so the GCF is going to be that minus 1. So that's the new thing, right? Sometimes you have to divide out something that you normally wouldn't take as a greatest common factor. You divided out a negative 1 so that identical twin showed up right here. So then you do the move of factoring where these 2 identical twins can be represented by 1 factor. And then the stuff on the outside, those are kind of like the leftover parts that create the second factor. And there it is. So let's see if that shows up on number 6 as well. So number 6, should we do any rearranging? I don't think so. Looks like 30 and 90, 30, 60, 90. I'm getting good vibes from keeping it as is. And these are both positive. Those are both negative, so it's a good match. So grouping the blues together. They both share a B. And they're both multiples of 30. I can take a 30 out of this one. And I can take a 30 out of this one. 30b, therefore, is going to be the thing on the outside of parentheses. It's going to be the greatest common factor. 30 divided by 30 is 1. B squared divided by b is a b. So 30b is on the outside of parentheses, and you're left with 30 over 30 is 1, 1b. You know what? I'm just going to keep it as b. Second part, the b divided by b is... There's no b's left. 90 over 30 would be 30, 60, 90. So you're left with a positive 3. All right, there's the blue group totally factored. The black ink group that's totally factored looks like, you know what? I'm trying to create a b plus 3 in my second set of parentheses. So you can almost like reverse engineer this thing and say, what do I divide this by to get that? Negative 5. Negative 5 divided by negative 5 creates the positive 1b in front. And negative 15 divided by negative 5 creates the positive 3 right there. So negative 5, that's going to be the GCF that you put on the outside of the parentheses. So then again, the identical twins can be represented as 1 factor. So these identical twins will come down to be b plus 3. 30b minus 5 will be on the outside. Now here's one new thing that you need to be on the lookout for. So I had 4 terms and I did factor by grouping. But look at this first factor here. Do you notice anything? 30b, 5, 30, 5, 5, 10, 5, 10, 15, 20, 25, 30. Okay, so you technically had a greatest common factor at the very beginning of this problem of 5. So here's what you can do. At the very end, to salvage this problem, to not create any waves, you can still divide out that 5. It's the greatest common factor of this first group. So then you put the red 5 on the outside, and on the inside, you're structurally 6b minus 1. Everything in the blue group, it stays as is. And that technically is the final factored version of that original polynomial. Okay, so check out number 7. If you're bold enough, hit pause and try it on your own. All right, let's see what you got. All right, first things first. Should I rearrange? Sorry, you guys can't see that whole thing. I guess I'm a newbie at this. Anyway, this is the one we're trying to solve. I'm going to keep it as is. I got two positives next to each other. They both share a B. I've got two negatives together. They both share a D. I think that it'll work if we keep these for the blue group and these for the black ink group. All right, so what do the blues share? They only share a B. So you're only dividing out a B term. So I've got a positive B on the outside. On the inside, I've got 3a squared plus 4c. All right. So whatever we divide out of this, I better be getting 3a squared plus 4c on the inside. So negative 18 divided by what gives me 3? Negative 6. All right, so if I'm dividing this by negative 6, I got to divide that by negative 6. They both also share a D, so put a D there as well. So stands to reason that the negative 6D should be out here. Now double check yourself, okay? Negative 18 divided by negative 6 gives us positive 3. The D's cancel, so then a squared with a 3 out front checks out for the first term. Negative 24 divided by negative 6 creates a positive 4. That's what we want. And then D divided by D is gone. There's a C left over. All right. The two identical twins become one factor. And then the outside GCFs also become one factor. All right, guys. Whew, I'm getting a little fatigued here, so this is going to be my last problem, number 8. Whew. All right. So should we rearrange anything here? I'm not exactly sure what we should do. I mean, 16 and 8, those seem to be a good match, and they both have A's. Let's just keep it as is. See what happens. So here's my blue group. And I think we're probably going to run out of room if I don't move this thing. So blue ink, black ink. So this first group, they both share an 8. And they also both share a squared. And I do believe that's it. So let's be very careful as we just determine what goes inside the parentheses. So 8a squared goes on the outside of parentheses. That's what it means to divide it out. 16 divided by 8 is 2. The a squared's completely canceled, and you're left with a b squared. Second part, 8 divided by 8 is 1. 8 to the 4 divided by a squared. Well, if you recall back in chapter 3, we talked all about properties of exponents. If you're dividing, remember, that's subtraction. It's just going to be a to the 2 power. So a to the 2 power is what's left over right here. Minus 1, a to the 2. I don't have to put the actual 1 in front, though. Okay, so now what we're doing is we are trying to replicate or recreate 2b squared minus a squared. And the question is, what do we divide these terms by to create the 2b squared minus a squared? Well, if you notice, I have a negative in front of my b term, and I have a positive in front of my a squared term. That needs to be reversed, which means we have to divide by a negative. They both divide 3, and there's a b squared on the second and a b to the fourth on the first, so they both divide at least b squared. All right, does that do it? Check it out. If I put negative 3b squared on the outside there, negative 6 divided by negative 3 is a positive 2. Got it. B to the 4 divided by b to the 2 is b to the 2, just same kind of calculations that happen here. It works. Positive 3 divided by negative 3 is negative 1. B squared, they cancel out. You're left with that. One last move. Our identical twins become one factor. And then the leftovers on the outside, 8a squared minus 3b squared, they represent the other group. All right. So this is kind of tricky. I would expect at our next Zoom meeting that you guys would have questions, or at least would like to see some of your homework problems worked out to, ensure that you're using the right strategies and you're not just guessing. So thanks for watching, and yeah, keep working hard. Good luck.